So this is a presentation on strange stars, which are an extremely weird kind of exotic non-sequence star. And now, strange stars are a form of exotic non-sequence star that are composed almost entirely of degenerate quark matter or quark plasma, and that would differ from a normal quark star in that a strange star would be composed of primarily strange quarks, up quarks, and down quarks, as opposed to just up and down quarks. Strange stars would appear relatively similar to a neutron star. The main difference would be that they would potentially have a slightly different magnetic field, and they are slightly smaller than a neutron star if they exist. But both would be ridiculously dense and would have incredibly powerful magnetic fields. So powerful that if you got close enough to one, the magnetic field would probably rip any ship or anything apart instantly. Strange stars would be a primary source of a thing called a strangelet, which is a hypothetical particle composed of up, down, and strange quarks in relatively equal proportions. If a negatively charged strangelet that is more stable than normal matter collided with normal matter, it would convert that into strange matter, potentially. This would not happen with a positively charged strangelet, because that would be repelled by the nucleus of any atom that it came into contact with. A good source of strangelets would be if a quark star or a neutron star that contains strange matter collided with another quark star or a neutron star. And now, what would create strange stars? Strange stars are likely created when a neutron star is too dense to be supported by neutron degeneracy pressure, but not dense enough to collapse into a singularity. This should also mean that they aren't very common, if they exist at all. But it would also be relatively difficult to figure out how many of them would be out there, because they would look very similar to neutron stars. So now we get to the meat and potatoes. Are they real? A strange star would be likely around 11 kilometers in diameter, which is a little bit smaller than the neutron star, so we could potentially see one if we could tell the diameter of the star. The neutron star RxJ18563754 was recently imaged with the Hubble telescope and Chandra telescopes. Its radiation signature indicated it should be burning at about 700,000 degrees Celsius with a diameter of somewhere around 11 kilometers, which is right in the range that we'd be looking for a strange star or quark star. There is also the possibility that strange matter might occur in every neutron star, converting all neutron stars into a strange star over time, assuming that it would be more stable than normal matter. You also wouldn't have to necessarily only have negatively charged strangelets for that, because since neutrons don't have a charge, positively charged strangelets could also convert neutron stars into strange matter. There's also the possibility of strange matter planets, which could orbit very close to their parent star. Recently, there were discovered 4 planets orbiting neutron stars at a distance of around 348,000 miles, which is well inside the smallest stable orbit for a normal planet. Anything that close would normally be ripped apart, but since these would be much more dense, they would be able to survive a little bit longer in that orbit. There's also the possibility, though, that strange planets could orbit as close as 14 miles above their parent star, skimming the surface of the star, and would likely be the result of strangelets colliding and converting normal matter into strange matter, possibly if a neutron star had like a hot Jupiter planet around it and then that got converted, or if it captured a planet that was a rogue planet drifting through interstellar space. And then my sources, we have space.com, published in 2019, skyandtelescope.org, published in 2020, another space.com source, published in 2018, and Popular Mechanics, published in 2017.